All right, today we're looking at the 2016 exam. This is question number 5. I've classified this as type 4 and type 7. I'd say it's a little more closely related to type 7, but since we have a volume question, I'll stick it in the type 4 list as well. So area, volume, and then calculus grab bag. So the inside of a funnel, height 10 inches with a circular cross section is shown in the figure above. At height h, the radius is given here from height 0 to height 10. The units R and H are inches. Find the average value of the radius. So this is a average function value question, and we're finding the average function value for radius. So 1 over b minus a to b f of x is our go-to formula for average function value. In this case, we are doing it for the radius. And the radius has a boundary or a domain of h going from 0 to 10. So 1 over 10 minus 0, integral 0 to 10 r of h. That's the integral expression that we're going to use to find the average value of the radius. So the 1/10 and 1/20 will pull to the front so that we are dealing with a easier to anti-derive expression. Slide this up. The antiderivative of 3 is 3h, and of h squared is h to the third over 3, and this is being evaluated from 0 to 10. So we get 1 over 200 times plug 10 in, 30 plus 1,000 over 3 minus 0 plus 0. That is our numeric answer. And if we were to simplify this down to a clean and concise value, we can find our common denominators, and it cleans out to 109 over 60, radius and height being measured in inches. All right, this is worth 3 points. You have 1 point for the integral, which I'm going to assume is without that 1/10 on the outside. So if you knew you're supposed to integrate that. You get 1 point if you correctly find the antiderivative of your integral, which I kind of lumped together with the 1 over 200, or the 1 over 10. So that's a little bit shady, but works out. And then 1 point finally for the answer. Okay. Integral, antiderivative, and then your final answer. All right, on to part B. Part B says find the volume of the funnel. And this is a rotation volume. So if we go back to our volume days, the general concept was we did big R of x squared minus little r of x squared. Now in our case, we only have one radius. So with just the one radius, we don't have to worry about a inner radius. So our radius is 1/20, 3 plus h squared. That's what our outer radius is. Our inner radius doesn't exist. If you wanted a placeholder, you could put a 0 in there, but since it doesn't exist, I'm not going to put in the placeholder. And this radius stacks from a 0 to a 10. Okay, now we have to go about solving this antiderivative by hand. So if I take the 1/20 and square it, I'm going to get 1/400. So I'm going to pull that 400 to the front. And then I'm going to square the 3 plus h squared, which gives me 9 plus 6h squared plus h to the fourth. And this is what I am integrating with respect to h. Fix that mistake there. All right, now we've stripped the context out of the problem and we're just doing old-fashioned calculus. The antiderivative of 9 is 9h. 6h cubed over 3 would be 2h cubed, and then h to the 5th over 5. And that value gets evaluated from 0 to 10. If we stick 10 into the equation, we get 90 plus 2,000 plus 10, let's see, 1, 2, 3, 4, 5, over 5. And then plugging 0 in, subtract 0. There's our numeric answer. If we were to clean it all out, 2209 pi over 40, and it's a volume, so cubic inches. This is worth 3 points. 1 point for the integrand, 1 point for the antiderivative. Again, I kind of lumped the pi into the antiderivative, but, and our last point right there. All right, and then moving on to part C. Part C says the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is 3, so when h equals 3, the radius of the surface of the liquid is decreasing at a rate of 1/5 of an inch per second. So the radius is decreasing at a rate of negative 1/5. Sorry, at a rate of 1/5. Because it's decreasing, we make a negative. At this instant, what is the rate of change of the height? So what is dh dt? That's the thing that is being asked. So right off the bat, if I know that the snapshot moment occurs at time h equals 3, if I stick 3 into the equation, I can find the r value. So the r value, I don't know if I need it, but would be 9 plus 3 is 12 over 20. Okay. So this is kind of, in our class, we set it up as our find when in our given. So find when given. The relationship between r and h is 1/20th 3 plus h squared. Or if we distribute that 120 through, we'd have 3/20ths plus h squared. Let's do 1/20th h squared. Okay. So we want to set up and take our derivative. So if we take the derivative of this with respect to time, that's going to find our relating rates. So the derivative of the left, dr dt, and the derivative of the right would be 1/20th times 2h times dh dt. Now let's plug in all of our knowns. dr dt is negative 1/5. 2 times h is 6. Put an extra 0 there. And then dh dt. If we solve this equation for dh dt, we'll get negative 20 over 30 equals dh dt, or the height is decreasing 2/3 of an inch per second when h equals 3 inches. So that's the complete sentence structure. This is worth 3 points. You get 2 points if you did the chain rule. So if you remembered to take the derivative with respect to time, specifically catching that dh dt part right there. That's your first 2 points. And then your last point comes from the answer, which is either negative 2/3, or you can write it as the sentence. Let's be safe and go with the way they have it, because we don't need to express it in a complete sentence. And does it ask for the units? It doesn't ask for the units, so there's no points awarded to units. All right, thanks for watching. Ask good questions, conquer the world.